Okay, for the procedure, firstly, measure the dimension of the disc and axle by using proper instruments. Repeat the measurements and take the average results. Okay, next steps is connect the 3 weight hangers into the strings so that all 3 weight hangers are in equal positions. Okay, step 3 is measure the distance from the floor level until the end of the hanger as H. Ensure all the 3 distance are equally. Okay, the step 4 is remove the locking pin. Lift up the hanger by rotating the disc with 1 revolutions. Okay, and on the next step is after 1 revolutions, hold the handle with the locking pin. Measure the travel distance for all 3 hangers and record it as H1, H2, H3 as shown in the table. Okay. The step 6 is calculate the distance travel, which is S for all the hanger, where S is equal to H final minus H initial. Okay. The step 7 is repeat step 4 until 6 with the increment of 1 revolutions until the 3 revolutions. Okay, the next step is plot the graph of distance of travel, which is S versus number of revolution of N. Okay, the last step is calculate the angular velocity for the hanger, which assume is 1 revolution take 1 second. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nabil bin Hanis. My ID number is 2019257768. Okay, I want to present about the experiment wheel and axle. Okay, the objective of the experiment is to investigate the relationship between the angular rotations and the tangential motion of the shaft, and they'll be confirming that V equal to RW. W is a angular velocity. Okay, this is the result that we get from the procedure that we make. Okay. For the this result, also the result for the distance travel, which means distance travel in millimeter is equal to final height in millimeter is minus initial height, which is in millimeter also. Okay, the example calculation for the distance travel is assume that for 1 revolution is 676 millimeter, that we can get for the revolution 1 in hanger 1 minus 439 millimeter. For the initial height equal to 237 millimeter. Okay, next is the graph for the 3 shaft that we make in the experiments, which is the shaft 1 for the blue line, shaft 2 for the red line, and also the shaft 3 for the green line. The graph present for the distance travel in seconds versus the number of the revolution of the in the N unit. Okay, we assume that the 1 rotation is equal for the 1 seconds. So we make a calculation for the angular velocity, which is a number of rotations multiply by 2 pi divide by 1 seconds. And we get the 6.284 radius per second for the 1 revolutions. And for the 2 revolution is 12.57, and 3 revolution is 18.85. For the tangential velocity, the example for calculation of angular velocity is tangential velocity for 1 revolution of shaft 1, which is V equal to R multiplied by angular velocity. Example is for the shaft 1, 0.0375 multiplied by 6.284 for the 1 revolutions that we get for the 0.24 meter per second for 1 revolutions. Okay, for the discussions, the first question is compare and discuss the result from different types of shaft. Okay, the table shows that the composition of shaft. The expression is from the table 1, shaft 1 has more value of distance travel for 1 revolution than shaft 2 and shaft 3. It because the average diameter of shaft 1 larger than shaft 2 and also the shaft 3. The increasing of diameter shaft will increase the distance travel in 1 revolution, which is S1. Okay, this is the graph that based on the result that we get, which is a graph radius and distance travel. The graph shows that the distance travel increase will make the average radius will also increase. Okay, the expression is average radius is proportional to the distance travel, as we know distance travel which is pi increasing when the radius of circular increase. To relate with the objective, the increasing of angular velocity and angular rotations, it will increase tangential of movements based on the formula V is equal to R multiplied by W, which is angular velocity. Okay, the next discussion is give your comment or suggest at least 4 causes of error that may affect the result of the experiments. My answer is error that can occur in experiment is systematic error. For systematic error, it can be observational error. For example, parallax while reading meter scale. Next, environmental error. This error can exist when environment of the lab contribute to inaccurate result, like vibration of the apparatus that cause of earthquake. Besides that, instrumental error also can occur if an instrumental itself is faulty and offer improper reading. And lastly, theoretical error can occur when experimental procedure, a model, systems, or equation generate inaccurate result. Okay, the next question is explain how the theories in the experiment give effects in some real life applications together with examples. Okay, my explanation is in reality, the theories can predict many of the factors that are involved. Your institutions can accurate. For starter, we know that if we push too close to its hinge, a box moves slowly. In addition, we realize that the more large the box is, the more slowly it's open. The first instance indicates that the further force from the pivot is applied, the greater than angular velocity, the angular accelerations. After that, another consequence is that the mass is inversely proportional to angular accelerations. This relationship should look very similar to the familiar relationship expressed in the Newton's second law of motion between force, mass, and also the accelerations. Okay, for the conclusion of the experiment, we can conclude that tangential movement has a relationship between angular rotation because the value of the tangential movement depends on the value of angular rotations. During the experiments, we must avoid any error that can occur because it will affect the result of the experiments, such as reading the scale must be parallel to the meter scale. Finally, to get a more satisfying result, we can clean the apparatus before and after an experiments to make sure that apparatus in good conditions. That's all for my presentation. Thank you.